Good afternoon. My name is Bethany Maddox, and I'm a member of the customer care team here at Vitech Corporation. I'm very pleased to be your host for this webinar as we welcome Michael Bruchanski, presenting his work on system analysis and visualization and adding that to MBSE by integrating his AGI systems toolkit with GENESYS. Before we get started, I'd like to take a moment to review a few technical details. First, questions. Please feel free to submit your questions at any time via the Q&A function in the GoToWebinar window. We will be monitoring these throughout today's event. We plan to respond to questions at the end of the webinar, so please send them in. Finally, recording. The webinar is being recorded today. If you're having technical difficulties with this presentation, an online archive with this presentation will be available within 24 hours of the live version. I believe that takes care of the housekeeping matters, so let's get started. I'd like to take a moment first to introduce our presenter. Michael Bruchanski is a product marketing manager at Analytical Graphics Incorporated, where his primary focus is visualization and analysis software for unmanned aircraft systems. Prior to working for AGI, he worked as a software engineer for the Boeing Company and Sikorsky Aircraft on various helicopter programs. Michael holds a BS in Aerospace Engineering from Embry-Riddle Aeronautical University and an MS in Computer Engineering from Villanova University. Please join me in welcoming Michael Bruchanski.
All right, thanks a lot, Bethany. Before I get started, I'd just like to say thanks to Vitech for letting me come and present, and thanks to everybody that is attending today. Like Bethany said, my name is Michael Bruchanski. I'm a product marketing manager for AGI. And at AGI, we're a small commercial software developer. We make software for the aerospace and defense industry. And our flagship product is something called STK. It stands for System Toolkit. As you might expect from my fairly lengthy PowerPoint presentation title, what I'm going to talk about today is integrating STK with GENESYS, how to do it, showing a simple example, and talk a little bit about why you would want to do that. Before I get started with specifics about the integration, I want to give you a little background about STK for those of you who are unfamiliar. So if we get started, we might look at our systems architecture in a tool like GENESYS or Core. And we have the representation of our system and its parts, and they might include references to the aircraft model. Let's say we're talking about an unmanned aircraft. We might have aircraft model representations, sensor model information, or communications model, all the various important parts of the subsystems, the requirements for those. And they might be mentioned or listed somewhere in our systems model, but they're not necessarily integrated with each other. And that's one of the things we can do with STK. We can use it for collaborative system design and analysis. So if I start with my aircraft model, and by my aircraft model I might mean the physical representation of the model, the size and position of all the components, also the performance of that aircraft, so how fast does it go, how high does it fly. To that I can add my sensor model. So I know that my sensor, if I use an optical sensor, whatever sensor type I have, it might have a certain resolution or capability as it stands on its own. But when I place that on my aircraft, it goes at a specific location, and I can look at, in STK, placing my sensor model at the specific location and combining it with my aircraft model. So as my aircraft maneuvers, maybe it turns and banks, that will affect the ability of my sensor to see things. Additionally, if I have while iterating on my aircraft model, if I add a new strake or a piece of structure to my aircraft, that might impede the view of my sensor, and I could see that and model that very easily within STK. Similarly, with the communications model, especially if I'm looking at an unmanned aircraft here, communications are very important to me. Just like with the sensor, my antennas aren't ubiquitous. They exist at specific locations, and the various locations that they exist at may affect their performance. Also, as my aircraft maneuvers, that affects my communications performance, and so on and so forth. But what this allows us to do inside STK is get a full representation of our aircraft. So now we see not only how each of the systems will work, but then how they'll work collaboratively. Additionally, we can look at mission-specific analysis. So I know this unmanned aircraft, as I'm looking at here, it doesn't exist in a vacuum. We didn't build it just to put it on a stand somewhere. We have missions, and those missions can vary, different locations, different purposes, and we need to be able to exercise our systems to make sure that they not only function together, but function in these different mission environments. If I'm flying my aircraft over the mountainous region of Afghanistan, it might be affected differently than if I'm in Singapore, where it's hot and humid and it's not as mountainous. So I can look at this to understand each specific mission thread and evaluate my system as a whole. So if I take my unmanned aircraft, I want to take a picture of something. Well, I need to use my sensor to take that picture. I need to fly the aircraft to put it in the appropriate position, and I need to communicate that picture up through my communication means to whoever wants to view it. So we can view that all in STK, and then here we have a representation, this colorized heat map that shows what we're able to see and how well we can see it. The ultimate goal is for end-to-end system design. So I start with whatever requirements I have or whatever my system model might be, like I said, in Core or GENESYS. I iterate on that model, I combine, I get a full representation throughout the system together, and then also as we implement that system, and then I incorporate that analysis back into my system model. So how do we do this in SDK? What are the models that we can use? Well, we have a couple different models. So SDK focuses on dynamic objects. So one of the things we start with is vehicle motion models. So I mentioned aircraft here. Previously, SDK originally started as a satellite tool. So we can model the motion of aircraft, satellites, ships, ground vehicles, underwater vehicles, or of course, static objects like facilities. And we want to look at their position and attitude because that will affect their subsystems. Additionally, we can apply sensors. Like I mentioned previously, we can add a sensor to any of these objects, and that sensor might represent a radar, it might represent an EOIR sensor. We can look at how they're pointing, how they'll be affected in different missions, and also their environment, which leads me to the next point. We model the environment very specifically in SDK. We can model everything from the terrain on the ground to the atmosphere, different regions of the atmosphere, all the way up through space weather. As I mentioned, SDK is a very powerful satellite tool as well. We can model missions on Jupiter as well as we can model missions on the Earth. And then one of the very specific models that we have our customers use fairly often are our comms and radar models. Again, it's designed to be dynamic. So we have models of things like radar cross-sections, communication devices, both in space and on terrestrial means, and we can show, again, their performance across a mission. The next thing we do is we take these models, we combine them in such a way that they model our system, and then we produce some type of analysis. In this case, we want to either simulate a mission, calculate the performance, evaluate how the systems work together, or explore some different design space. We have the ability to not only calculate this, display it in a way that makes sense, either through graphs, reports, or visually, which leads me to the next section. One of the things about SDK that most people notice very quickly, very early on, is our 3D and 2D visualization. All the pictures and videos that I've shown so far, and the ones I'll show throughout my presentation, are directly from STK. We have the ability to model objects, so aircraft, any different type of aircraft, ground vehicles, ships. We can model the terrain, so we import terrain sources to represent mountains or urban areas, and then we can convey these results in graphs, reports, charts, videos, images. The idea being that the visualization isn't the end product of SDK, the analysis is the end product, but taking some of these complicated concepts, we are easily able to explain them and demonstrate them to various stakeholders who may or may not be as technical using this 2D and 3D visualization. Okay, so talked about modeling the system, the different models that we have available. We talked a little bit about analysis, that we can produce some analysis, and then the ability to convey results. So these are the core tenets of SDK. To that, we can apply this ability to collaborate, the sharing models between different users, and then most importantly for this conversation, the ability to integrate. So we can integrate SDK with many different tools, and that's specifically what I'm going to talk about in the next upcoming slide. So if we look at the reason for integrations, so I'm going to level with you right now, everybody that's listening. I don't know a whole lot about MBSE. I'm kind of new to the whole systems engineering game. Besides some requirements work I did very early on in my career, it's only been about 1.5 years I've kind of been re-engaged it with MBSE. And one of the things we like to do at AGI is when we get a hold of our user who is brand new to our tools like STK, we like to get in front of them and learn about their experience. What we found is that a new user has a lot of good insight. They can tell us things that don't make sense or things that they don't understand, whereas somebody that may be an expert of our tools might have, can share a lot of responses and comments about what they'd like to see changed, but it's the person that just uses it has a lot of real valuable insight. So while I was learning about systems engineering and MBSE, I was very cognizant of that. And so one of the things I've learned in talking with AGI's customers who are interested in MBSE, the folks at Vitech, and then other people through conferences, is one of the first things, if you ask somebody to explain systems engineering or specifically MBSE, they talk about moving from a document-driven process to a model-based process. And so I heard that, I said, okay, that sounds great, I'll buy that. But in my mind, coming from the kind of modeling and simulation world, I had my own cognitive bias as I learned about this. To me, the M in MBSE, I thought referred to what I learned is called the executable models, the SDK scenarios, your MATLAB models, your CATIA models, your Nastran models. And I realized that wasn't necessarily the case. So as I talked to people, I said, well, okay, if the model you're referring to is really your system model, how do you interact or how do you integrate the executable models into your system model? And everybody said kind of something along the lines of, well, we don't really know how to do that, but everybody wants to, and there's no real well-defined way. It kind of depends on your process. And so one of the things I thought is like, okay, well, I understand the ability that you want to move from a document-driven process to a model-driven process, but what we've kind of done is if I'm a modeling and simulation engineer, I'm using SDK, and my colleague is using GENESYS, I'm not using physical documents, but I'm really still kind of using documents. I'm sending information back and forth. And what we can do with tools like SDK and tools like GENESYS that are commercial tools with robust programmatic interfaces is we should be able to link these directly. So I want to move from an e-document driven process to an actual direct linkage. So the goal would be not to replace and say, okay, one person uses every tool, but to say to the guy that uses STK and the guy that uses GENESYS, if you need to exchange information, then that could be done directly now. And the idea would be, I want to reduce the time it takes to iterate on these designs. So if I need something from STK, I need a piece of analysis, I can zap that right into GENESYS, either by the STK user or the GENESYS user. As my requirements change or my system model changes in GENESYS, I should be able to zap that change into STK. This will allow people more access to the different pieces of analysis and allow more people to verify the system as they go through the different iterations. Now, by no means am I saying that this will start and end with STK or GENESYS. At AGI, we have a specific corporate initiative we call MSAF, which is similar to this. We want to integrate STK with many other tools, tools that our customers use, so that rather than having these different stovepipes, we might have still these expert users, but the tools are interacted for exchanging data. So that my SDK user sees information in tools that in SDK like they're used to seeing, and my GENESYS user might see SDK information in GENESYS, but it's in a format that they're familiar with. Additionally, one of the things that I came across is we have these very complicated system models that get developed. And although it makes sense to a systems engineer to show various diagrams and representations that systems engineers are used to seeing, sometimes it can be confusing when communicating that to stakeholders. That's something I heard at during a couple presentations at the last INCOSY event, and something that I kind of understood, although some of the diagrams kind of make sense. It takes a little bit of explaining sometimes to let somebody that's really unfamiliar with this process or the system you're talking about to understand it. Whereas in SDK, it's very graphical, so we can kind of get some easy representations of our system. Now the goal would be, one of the things also that I learned as I learned about systems engineering is it seems like you're required by law to have some kind of representation of the systems engineering V. So this is my homage to that. But one of the things we want to talk about is that this combination of these tools, it shouldn't exist in any part of the process. This isn't something we do for detailed analysis or ConOps or test and evaluation. The ideal situation would be that we start from the very left side and we integrate these models, so as we iterate and we develop, we get a full representation of our system, so that when it comes to test and evaluation, we have a good model, a good representation of our system, hopefully improving the process, speeding things up, and discovering errors earlier and earlier. Now, one of the things that we like at AGI about Vitech tools is that they have some specific capabilities that they've evolved towards test and evaluation. And so we have a lot of mutual customers that use STK for test and evaluation of their products that also use Vitech. So to us, that's very valuable. Okay, so one of the things I think that hopefully, or maybe some people listening are thinking in their mind is, obviously this makes sense. Taking a logical next step of MBSE or systems engineering, expanding beyond our system model into the tools that we're using to develop that model. Okay, that's good, but the problem is the execution of that can be difficult. And so what I want to show is an example integration. I certainly recognize that many systems engineers are used to starting with a set of requirements, and they work out from that set of requirements. But those requirements don't necessarily come from the ether. We have a lot of customers, STK customers, that sit on the far left side of a product or a program. They use SDK to develop the basic initial ConOps for a system. And so what I want to look at is kind of a model for those customers. We would start with SDK, developing initial ConOps. We're going to, from within the SDK GUI, communicate what we've created in SDK to GENESYS, and then have GENESYS create the linkages between the subsystems, take information from SDK and populate it in the appropriate fields, and then finally I want to see some information back in SDK. Now the software in this case that I've used to do this is SDK version 10.01 and GENESYS 1.1 Service Pack 5. Before we can do this, we need to look at the different APIs. So luckily, STK and GENESYS are commercial tools. We have a lot of customers, and I've experienced myself a lot of in-house tools that you might use at your organization that have been developed by some intern or someone who's since left the company that are difficult to integrate with. Not the case here. In STK and GENESYS, they both have a .NET API, which is great. .NET is easy to use. It's very flexible. And that's what I looked at here. Now, beyond the APIs just being compatible, we got to figure out how to use it. So SDK comes with installed examples, and GENESYS also comes with a set of installed examples that show you how to use some of the capabilities that are part of the API. I found that probably in my simple example, which I'll show you in a minute, about 80% of what I was looking to do was already outlined in this installed example as simple cut and paste, or maybe some small changes, and I was up and running. Now, SDK and GENESYS, both commercial products, have tech support. AGI, we have tech support, or SDK has tech support. We have good tech support. Most of our customers speak very highly of it. With GENESYS, I found their tech support to be outstanding. It was great. They were very responsive. They listened to answer my questions, listen to my feedback, listen to my just kind of random whining in certain situations, and they were very helpful, and I'll get back to that in a second. With SDK, we have a fully documented API. It's been around for 20 years, documented backwards and forwards. The only real knock that I had on GENESYS, or the only real negative experience I had, was the documentation is still in development, so I'd get to a point where I just need some help. Maybe a better programmer could have figured it out, but there wasn't enough documentation for me to get to the end of where I was trying to go. Which brings me back to the outstanding tech support. This was easily solved by a quick email or a phone call, and they sent me code. It was super easy. They're very, very, very helpful. The next thing to talk about is something we call UI plugins in SDK, and that's the ability to customize the GUI, embed your own custom code in the GUI in a way that's transparent to the user so that it looks like it was developed by AGI. I use that in this case. In Genesys, they don't have that, but they have something probably just as good, if not better. They have an area of where they have basically a .NET compiler, essentially, that you can develop in-application scripts. So you can write scripts from within Genesys, execute them whenever you want to, and have them access the API just like it was external. Super easy. SDK, we talked about our visualization earlier. Genesys actually was surprised to learn that you can export different diagrams, which was great because I wanted to do that, and it was really easy to do. So basically, through our API, everything worked out. We were set up for success with regards to that. As far as the specific implementation for the example I'm about to show, in this case, since I'm not a very good programmer, I use VB.NET. I wanted to use some .NET language. Using .NET means I had access to things like IntelliSense, I had some references, and then I'm off and running. As I mentioned in the previous slide, I want to use a UI plugin, which means that an SDK will have a custom context menu. So all the code that I need for the interaction with SDK and between SDK and Genesys was embedded or contained within this UI plugin. So everything from logging in, sending information from SDK to Genesys, setting up links, and returning information from Genesys was all contained in this tiny application. One, I guess, I won't call it an issue, kind of issue that I ran into early was the difference between the data models. So Genesys, when you start it up, you can choose kind of the schema you want to see, but in SDK, it's designed for very specific implementations. So first of all, there's this concept of, as opposed to a system model which might say, well, I have the GPS constellation and I have my unmanned aircraft, in SDK we have to model things in a very specific time and place. So that context is not necessarily immediately available in Genesys. Also, SDK has a lot of fields that you use to set up the different assets in your scenario. It has outputs, lots of analysis, and I needed to do something with it. Initially, I kind of was just jamming it into various fields that I had available to me, but after a quick conversation with the folks from Vitech, they said, you shouldn't do it like that. Here's a better way to do it. And so there is the ability to create a custom schema within Genesys, so you can start from whatever your DODAF schema that you're using, and you can add custom objects. In this case, I added a bunch of components that represent objects within SDK. It contain their own properties. I went and I changed the colors that showed up on the diagram that was amusing to me. And again, this is probably a 5-minute conversation. Do it like this, here's how you do it. The only downside was that SDK has a lot of properties to it, and so I only did a couple things just to do an initial representation. That's really an SDK issue. Okay, so specifically, let me show a demonstration. In this case, I want to look at, I am in the Navy, I'm doing a U-class concept of operation development. I want to model navigation and communication system for my unmanned aircraft. In this case, I want to look at not only my system that I'm interested in analyzing, the aircraft in this case, but also the other systems that it needs access to. So things like GPS, satellite communication. So those are systems that I don't have any control over, but I still need to know how my aircraft will interact with them. Also, this is a carrier-launched aircraft. I want to have a ship, and I want to have everything moving. And then I want to have this scenario as a basis for my Genesys project, and then explore my system in Genesys. So I am going to jump over to SDK. For those of you who are unfamiliar, this is what SDK looks like. In this case, I have a 2D and 3D representation of my system. I have control using my mouse of both my 2D and 3D. In this case, If I zoom out a little bit, like I said, I wanted to represent my communications link, my GPS link. These cyan satellites represent the GPS constellation. Now, of course, there are a subset of those just to keep it simple. This blue object here, that's my communication satellite. And if I zoom up, we can see I have a representation of my unmanned aircraft, and this cone represents the field of view for its communication devices. Now, I can animate this. Unfortunately, the animation doesn't come across very well over GoToMeetings like this, but take my word for it, I'll move around, everything will zoom around. I also have a couple things. First of all, we can see, in this case, the comm satellite I'm using is this Inmarsat satellite. It has, in SDK, we have a basic hierarchy as part of our scenario. It's object-oriented. So my Inmarsat has a bunch of transmitters and receivers that are associated with it. They all have properties. And so I'm going to use this kind of hierarchy as a basis for setting up my different diagrams and the linkage between my object. If I look at one of these objects, here we can see the property panels that I referenced earlier in SDK. There's a lot of properties, everything from how this shows up to radar cross-section, and even things just like the description. So here, this is the GPS satellite. It's an actual representation of a certain satellite, and it's important that we know this when we're designing our system, even the concept of operations, because maybe we were designing for the next version of GPS. We need to make sure that we have this all annotated. So there's a lot of properties that I have set up in SDK, and what I want to do now is I want to export this data to GENESYS. So like I said, I'm in my SDK GUI. I'm going to right-click, and I have this custom menu. If I click on it, export to GENESYS, I don't have a lot of options. All I can say is, first of all, I want to give myself a name. I'm going to call it ConOps U class, and I have the ability to create a certain amount of diagrams. Here I'm going to say I want a hierarchy diagram. What that's going to do is when I load all this information into GENESYS, it's going to send me back a diagram for visualization in SDK using the GENESYS API and the ability of it to export its visualization. So here I'm going to click export. GENESYS has a certain login procedure, so I need to log in automatically. I am creating a brand new GENESYS project. I am exporting all the objects that are in my SDK scenario, so everything listed on the left-hand side, as well as their properties. It's creating those objects and those properties in GENESYS, and then creating linkages between them. The last step here is it's taking the hierarchy diagram that I've checked here, and it's creating that as an image, and then it's opening it up here in SDK. So now I'm done. We can see this is a direct representation from GENESYS. I have a hierarchy diagram. We can see the same parent-child representation here. So this is my Inmarsat satellite. It has all these antennas and receivers and transmitters as part of it. If I look at my carrier here, which is represented by this object, it has a couple different sub-objects. So that's the hierarchy that I'm following when I create my project in GENESYS. Now I can't really do much with this diagram. It's just an image. I just want to see it in SDK. But if I go into GENESYS, which is here, where are you? I can open up this project in GENESYS. And so this was automatically created just right now as I click this button, and we can explore my system in GENESYS here. So I'm going to start with, we can see that as part of my database I have these new objects that won't be part of your GENESYS installation because I made it as a custom schema. I'm going to go to the top level SDK object, which is called a scenario. We can see my scenario represented here, and I can look at that same diagram that I saw a representation of in SDK. Now what I can do is I can look at, as this diagram is now interactive, if I click on one of these objects like the GPS satellite, we can see all the pieces of information that were contained in SDK, so specific information about SSC number, which is like a satellite identifier, the name, all that kind of stuff, which we got from SDK. But then also if I jump to my ground station here, We do have some properties that aren't necessarily contained in my default GENESYS schema, things like my latitude and longitude for my facility. So I'm saying that this Kauai facility represents my ground control station for my aircraft. It exists at a specific location on the globe, which is a property of this object, and I want to specify that. Eventually, it would get to the point where we could change this longitude in GENESYS and say, well, I want to move this facility. And we could change it and then see that change be communicated into SDK. So this was kind of a very simple example. If I go back to my PowerPoint presentation, the idea being that we could create this interaction between SDK and GENESYS that allows us to fully interact throughout the life cycle of a program using different projects. And I'll say I'm kind of a nightmare customer in this case. I know, as I mentioned previously, next to nothing about MBSE. The first time I ever used GENESYS was when I started, when they sent it to me, so I didn't have any previous experience. I barely even opened up Core. And on my best day, I'm kind of a marginal programmer. But even with that, this was fairly easy to do. It didn't take a lot of effort. I had to ask a few questions and go through their example, but this kind of interaction, although very simplistic, was easy. We've shown this to a couple of mutual customers. They're very excited, and so I think we're heading in the right direction with this type of interaction. Now, just finally, for those of you who are unfamiliar with SDK, if you want to check out SDK, we have a free version. You can get it from our website. We have free training. Also, if you want to look at some of the demonstration of our paid products, you can request a demo. I'm sure my information will be listed on the Vitech website as part of this webinar, but if not, contact folks at Vitech and they can put you in touch with me. With that, I'm happy to answer any questions.
Thank you, Michael. Let's go ahead and move on to questions from our audience. We already have a couple of really good questions. Thank you to the people who submitted those. I encourage everyone to join the discussion and submit your questions at any time through the Q&A function in the GoToWebinar window. Let's get started, Michael. Your first question is from Henry, who asks, where did you get the models for the GPS satellites and the communications satellite?
Okay. Yeah, so by default in SDK, it's a toolkit, right? So we give you the ability to create whatever model you want. So you can create a satellite, you can create its orbit from whatever information you have. But for things like GPS satellites and communication satellites, things that already exist and we have some public information about, we have something called a standard object catalog. So you can say import the GPS satellites and it'll set them up. Same thing with the Inmarsat satellite. You say bring in Inmarsat and we have some information about it. So in that case, we have some standard objects that you can bring in.
Thanks. Our next question is from Amanda, and she wants to know, how do you know the model of the ConOps you develop is realistic?
Yeah, so I guess the answer is it's a garbage in, garbage out situation. If you make something that's unrealistic, then it's not going to be realistic. But SDK models the physics, the things like the communication RF propagation, and it's been validated and verified. We also have 40,000 customers out there who are constantly using it, and so for the SDK part, it definitely has some verification for it. You can find out information on our website about the different verifications that we've done.
Okay, one more from Jim, and Jim wants to know, how long does it take to become proficient in SDK?
Sure, that's a good question. It's something people ask. The answer is it really depends. I would equate SDK to something like a CATIA tool or a CAD tool. If you sit down in front of it, just like if you sit down in front of a CAD tool, you can probably draw a line and some shapes, but you're not going to be building a 747 without a little bit of training. So we have free training. We also have tech support that comes with our software, and so at AGI we'll do anything we can to make sure we can enable you to learn our software, but it takes a little bit of training. It's not super complicated though.
Great, thanks. That wraps up the Q&A for today. Thank you, Michael.
Thank you.
If we weren't able to answer your question during the Q&A portion of the presentation, we will contact you directly after the webinar to ensure that your question is answered. If you have other questions or comments that you didn't send in today, we invite you to post those on the forum of our community site. You'll find that at community.vitechcorp.com. Also, I hope you'll join us for the rest of our webinar series throughout May and June. For details and registration, please visit our website, vitechcorp.com. In closing, I'd like to thank Michael for presenting today. I'd especially like to thank all of you for joining us. As we bring this webinar to a close, a survey will open on your screen, either in a new browser tab or in a new window. Please take a moment to provide us with feedback on today's presentation and what topics you'd like to see covered in future webinars. If you'd like a personal tour of GENESYS 2.0, please let us know in the survey. Thank you for joining us and have a great day.